let's see. I'm just going to do these two sections, and then I'll give you some time to do some problems, and then at some point I'll give you a little break in there too, and we'll be done. So I don't, how do I say this? Let's see. I just do what needs to be done, and I keep an eye on the time. But I'm certainly not gonna, I'm not here to keep you over. And if we're done, and we're done, then we're done. Right? So I don't know. I mean, tonight I don't think we'll go to 8:20 tonight. And at some point I might tell you, well, we've got about half an hour or so, and we'll be done, or 15 minutes, or something like that, and we'll be done. Just so you have a. I know some people want to have bus things they want to be aware of. So just so you have an idea of when I think we're going to be done. So, but anyhow, so let's see. The first couple sections here, the first one particularly spends a lot of time talking about functions, but doesn't spend a whole lot of time talking about relations. So, now my assumption is that you've taken some sort of math classes, or else you wouldn't be here. So you either took 95, or you were placed in here because of what you've done prior to coming to college. You have to have a solid math background. So I'm assuming a little bit that you know some things about functions. All right. So let's talk, before we talk about functions, let's talk about what a relation is. Okay, so a relation is just basically a correspondence between two quantities. And you probably know these two quantities as like x and y kind of thing. All right, that's what a relationship. So it's just some sort of a correspondent. Okay, so between two quantities. Now they don't have to be numbers. They can be other items. All right, and I'll try to give you an example of that as we go through, where they're just not numbers. All right, so a relation is this correspondence. So what I was thinking about when I was thinking about this yesterday was, what if I went and drew a little graph like this, and I put down here time and wage. And I'm going to make this pretty simple, but that's okay, because I want you to learn concepts. I'm a lot bigger on concepts, teaching you that, than I am, here, memorize this and then regurgitate it on a test. That's not what I'm about. Okay, I'm not even going to put any numbers on this. I'm just going to go like this. All right, and kind of draw that kind of thing. Okay, so here's some time down here, and here's some wage on the side. And this would be a relation because there's a correspondence, obviously. The more time that you work, if you're working a wage sort of a job, then the more wage that you would earn. And this would be in a nice, we would say a linear, possibly, depending upon the scale of the graph, all right, of a relation. Okay, more time, more wage. All right, same thing here. What if we do the same thing, time and wage, but it's changed a little bit so that maybe it looks like this. All right, still we have a correspondence between time and wage, right? We're following this okay? All right, there's a correspondence there. And I can continue to draw some of these sort of graphs. All right. Now this one wouldn't be so good because nothing's happening much there, right? But you're still getting a correspondence, okay? There's still some sort of a relationship between the time and the wage, even though I'm not earning it. I'm just kind of stayed constant there over this amount of time. All right. Maybe that's like some sort of a salary position, all right, where it doesn't really matter how much time, I'm going to earn the same amount of money either way. All right. But that is a correspondence or a relation. So all three of these graphs show a relationship, all right, between time and wage. Time and wage. This is my last one, I promise here. Oh, that's nice. I work a certain amount of time. I just keep going. Man, I gotta find that job. All right? Doesn't matter. So, all right, here is another relation. Even though it's only one time and it has a number of different wages, I don't exactly know how that works. But that's a relation. Okay? So anytime we have a correspondence between two quantities, that's what a relation is. Now, inside of all relations are functions. All right? So they're a little bit different. So a function is a relation, okay, such that for each, I want to say element in the, and I want to put the word input here, all right, and I want to put in parentheses domain, all right, there is only one output, oops, or range. Okay, so this is a function. Now you want to think of it as input and outputs, but those have mathematical names, domain and range. Now that's the thing I think you probably know a little bit about. Have you heard of domain and ranges before? Yeah, usually like this. Yeah, I figured you did. All right. Now hopefully you've heard of it in terms of input and output. All right, and hopefully somebody has told you that a function is a relation such that for each element in the input, there's only one element in the output. Hopefully you know that, because that's a key idea behind a function. So if we go back to this graph here where I had this thing going like this, this would be a 1. Here's one element here, 1 to here, 1 to here, 1 to here. Okay? That's a function. There's for one element on the time, there's one element in the wage. All right? All right? That's a 1. That's what they're talking about. In fact, all of these up here, except for one, they're functions. Okay? This first one here, that's a function. This one is because here's my time, my wage is increasing. All right? There it is there. This one, same thing. Okay? My time's going, my wage is flattening, but still, if I work 1, 2, 3, 4, I'm still going to get one number for that. The one that doesn't work is this one. Because if I have a time here at 2, the problem is I have all these different wage opportunities that I have there. All right, so the 2 doesn't just go to one wage. Yeah?
So on the previous one, each point is a different function?
No, all the set of points is a function. The set of points. But in this red case, because of the fact that for the number 2, I've got 4 different quantities there, that doesn't work. That makes it not a function. All right? But the other ones we're okay with. So I want to try to give you somewhat of a visual for what functions look like and what relations look like. Pretty much everything's a relation. All right? And there's only there's certain things that are not functions. So let's go back to this again here. What am I drawing in this blue? Okay. And let's look at it from this point of view here. There's a couple different ways they have it. Oops. There we go. Okay, so they have something that looks like this. All right, and they ask you, hey, is this a function or not? Well, let's check. Now, normally we would say that the 3 and the 5 and the 7 and this 9, those are all your inputs. And then the outputs would be 5, 9, 13, and 15. So your outputs are going to be those numbers. I don't know what this function is. I just made it up. But I do know that if I put 3 in to the function, it's going to churn and kick out 5. And when I put 5 in there, it's going to churn and kick out 9. When I put 7 in there, it's going to tell me it's 13. And 9 is going to be 15. I don't even know if this exists, but that's what it does. All right? Input and output. So input mathematically is called a domain, which is our x's. That's how you probably know it as. And output is called the range, which is y's. That's probably how you know it as. All right? Because that's what that's what you've been kind of taught, and that's what you kind of connect with. All right? So here, our input would be 3, 5, 7, and 9, and our output would be 5, 9, 13, and 15. All right? And 3 goes to 5, 5 goes to 9, 7 goes to 13, 9 goes to 15. So yes, that's a function because one number here goes this guy, this one goes here, this goes here, this goes here. Okay? So that's a function. All right? So I just did a whole bunch of stuff there. Let's try another one here. Okay? 2 and 8 and 4 and 32 and 6 and 40 and one more, 8 and 56. Okay. All right. So domain, range. Domain's the input. Domains are x's. All right. So what would be in the domain? What would we write down here? 2, 4, 8. Outstanding. That's going to be our domain. And our range, what would that be? 8, 32, 40, and 56. Okay. So the question we might ask then, all right, so we know that. Now, so is this a function? Well, let's check. 2 goes to 8, 4 goes to 32, 6 goes to 40, 8 goes to 56. Is that a function? You bet it is. All right. Okay. Now, you know, sooner or later I'm going to come up with something to try to trick you. All right? Because that's what math teachers do. All right, here we go. Okay. So here's our input. And here's our output, domain and range. All right. What's a domain? 2, 3, 5, 7. So you see you're really good at that. And what's the range? Okay. Now I don't have to write, it's 9, it's just 9. I don't have to write it all the time. But notice what happens here. 2 goes here, 3 goes here, 5 goes here, 7 goes here. I don't know, is it a function?
It is.
Why?
The salary where time was added, but the wage was the same.
So it was kind of like this graph when we went like this, huh?
Yes.
Yeah. So the y is staying constant, but the x's is changing. That's okay, because our definition is that each of these has to go to only one of these. And you're saying it can be the same, right? Okay, good. Yes, that's a function. All right. Now what about this one here? 2 goes to 10, 3 goes to 12, 4 goes to 14, oops, 5 goes to 18, 3 goes to 20. Okay, here we go. Domain, range. Okay. Domain is 2, 3, 4, 5. Do I have to write 3 again? No, I already got 3 in there, so I'm not going to write it again. I probably wouldn't mark it wrong if you did. I'd just say, oh, you already got it there. And then what's our range? So 2 goes to 10, 3 goes to 12, 4 goes to 14, 5 goes to 18, 3 goes to 20. What about that one? No. Why not? There's 2 values for the 3, right? Okay, 3 is going to 12, 3 goes to 20, so that can't happen. Right. So there's that's it. You know, and if you've got a good feeling for that, then you're in pretty good shape for functions. All right? And what's going to be in that section. Okay? If you can do that, you're in pretty good shape. All right. Now, I bet if you know that, then you've probably heard of the vertical line test, which is a great way of deciding whether a graph is a function or not. Correct? So a vertical line test basically says that if a vertical line, you can put any word you want here, passes through, touches, intersects, it doesn't matter. It's your notes. You decide what you want to put there. I'm just going to put intersects. A graph in more than one point, not a function. All right, so the vertical line test really helps us out. That's going to tell us whether a graph is a function or not. So if we have a graph, I'm just going to do one by hand. All right, it looks like this. Okay, and I pass a vertical line through there, and it only touches it in one spot, we're golden. All right, so that's a yes. But if I draw another function, and now I pass a vertical line through it, and it touches in 2 spots, then no. All right, so that's no good. All right, and we'll do a couple examples. We'll kick open some Desmos here in a little bit and graph some things and talk about that and talk about domain and ranges. All right, but I'm assuming that you've seen the vertical line test a little bit before, but it's good to have a little review with it. Okay, so I said I would do some non-number things. I'm going to do it in a thing looks like this, a little T-chart here. Okay, so we got people on one side, we'll call that our input. We got birthdays on the other side, call that our output. Is that a function? What do you think?
Yeah.
Maybe. Give me an example where it's not.
Person can only have one birthday.
Person can only have one birthday, right? So it has to be a function, right? Okay. Now I suppose you might say, well, about February 29th or something like that, right? But, okay. Yeah, for the most part, this is going to be a function. Okay. We're okay there. All right. What about this? People. Phone number.
You can share a phone, so no.
So is it possible for a person to have 2 phone numbers?
Yes.
Yes. Work phone number, school, or your smartphone number, whatever. Okay, so not necessarily. All right, so this would be yes, maybe. This could be a no. So you're kind of getting the idea, right? Okay. How about this? Time, parking at a smart park downtown Portland. You got to think about it, huh? How does that work? How does that work?
More time you park, the more you pay.
The more you park, the more you pay?
Fee,
Huh?
unless it's a flat fee, but
So in a smart park,
oh, it's not hard.
how does that work? Nobody's ever parked in a smart park? Oh, no? You don't park in Portland. We don't even go down there. How about this? So you pay for 2 hours? So if you park for 30 minutes then, are you going to get a set fee for that?
No.
Yeah? They're going to charge you something, right? Is it possible then that they would charge you 2 possible fees for that? They can't. It doesn't make sense. So is this a function? Yes. Okay. You might end up paying the same whether you're there for 30 minutes or 45 minutes or 60 minutes. All right. That might be all the same value, but it's going to be a function, right? It's going to be 1-to-1. So there's some examples of that stuff. Let's see. So let's do some Desmo stuff, and let's see where that puts us at. 7 o'clock. Okay, let's do a couple Desmo things, and I'll get you a little break. So I'm going to have to. The only problem when I do that is I can't access the internet on here because they won't let me. So I'm going to have to switch machines here and do this and go to this. Okay, so if you've never done it, I'll show you how to do it. So you get on here. You can use your phone or your computer, whatever you want. We're going to type in DESMOS, okay, just like that. So I don't care which way you do it, right? You just want to try it out. Some of you have already done this, so it's going to be cool. You'll be all set. We're going to go into the graphing calculator part, and there it is. All right, so if you're using your phone, then you're going to get pretty much the same view. It'll be a little bit different, but not a whole lot. I have an account that I'll have things on there for you, and I'll give you the password and everything for it. That doesn't bother me because it's just a generic account. If you want to create your own, you can. It's not a big deal. It's pretty easy to do it. So down here, we get a nice little keyboard to enter things in. This is a very user-friendly app. If I want to graph something, all I got to do is go y equals, and I don't even really need to do that, but I think I will today, x. I'll just graph x squared, and there it is. Okay, so let me see if I can do this. I don't think I can, but I'm going to try. Nah, I didn't think I could. It doesn't like that. But this is obviously a function because if I pass a vertical line through it, how many times is it touching the graph? Once, right? The hardest part for students on this is figuring out what the domain and the range is by looking at a graph. Very difficult to do. And I wish I had the magic tools to figure it out myself. I tried a couple different things. This graph is extending onward, right? So if we take it and bend it down this way, and take it and bend it this way, would it cover everything on the x-axis? So then we would say the domain of this is all real numbers, all right? So you would simply write domain, not with that, you wouldn't. Domain, all real. Okay, you can just go all R. You can go double bar R. That's a symbol for that. All right, we'll just write all real, all R's. That's good. I know what that is. Okay, that would be the domain for that. Now the range, it comes down here, it hits here, bounces right back up. So the range is the Y. So what's the lowest y that hits? 0, right? It never goes below 0. So we would say that the range y is greater or equal to 0. Okay? It is one of the hardest things is trying to figure out what domain and ranges are from a graph. All right? And that's the best way I can think of is either by just taking this graph and bending it down, or taking it and folding it up, or thinking of just running a whole bunch of x's across there and y's, and what does it cover? Okay? Yeah?
Do you prefer set over or interval?
I'm not real particular about that. I just wanted you to be able to communicate to me what the correct answer is. So, no, I don't really care which. I probably would. I think interval notation is more common as far as what you would see than. Is that what they do in the back?
Usually that's how you do it.
Yeah. Yeah, I'm not going to ask you specifically what way to write it. Okay. All right, I'm going to just click on this. So now if I just kind of hold this down or click on it if you're using a computer, it goes away. All right, let's come down here and we'll put another one in. And I know you're probably getting a little anxious here. Y equals, let's go square root of x minus 3. Let's try that. Okay, so now I have this graph, okay? And this one's going on forever. You can trust me that it is. We can zoom out by if you want to do that. You can go plus minuses, or you can do, I don't even know what the word for that is on your phone if you're using a phone, okay? And you can zoom out quite a ways on it. But it's going that way. So, domain, let's think about this. We fold it down here, all right? What's the domain of this? All numbers greater than 3, right? Okay, so I would say this, domain, all right? X's, because we're talking about X's, greater than or equal to 3. If you want to do it in interval notation, okay, bracket is going to mean 3, right? Okay, and we're going to infinity with a parenthesis, okay? I don't really care which way you write it. If you want to write it out in words, that's okay with me. I just am more interested in getting the right answer. Okay, and you're communicating it. All right. Let's do the range on this. What's that? What's the lowest y that gets to? 0. So we have y is greater than or equal to 0. If you want to do interval notation, you do this. All right? It doesn't really make much difference. Okay? All right. One more here, and I'll get you so you can get a little break here. I'm going to keep this up here, and I'm going to go like this. And I'm going to change this to green, so it looks like it's all one. Okay, there we go. Now, so this is a crazy looking thing, right? Function? Why not? Because the vertical line is in 2 spots. Okay, so it's not even a function. All right, so then you would just kind of communicate that, say this isn't a function. All right. They're probably not going to ask you for a domain and range in that situation. All right. So I still got more stuff in 1.1 to cover, but that does cover quite a bit of it. I said I gave you, let's see, 7. Yeah, why don't you go ahead, take about 10 minutes. How about that? And come back. 5-10 minutes and come back. Okay? We'll do some more. Or stay if you want. I'm going to pause this because I just rolled in it here and resume it. Okay. The other things they want us to know how to do is, given a function, something like that, okay? Find a whole bunch of stuff. So one of the things they want us to do is be able to find some values and some things that aren't values. So for example, find f of 1, okay? They want us to find f of negative x. They want us to find f of x plus 1, right? They want us to find f of 2x. So they got all of this stuff, okay, that they want us to be able to find, given a function. Well, 1's easy because all we're going to do is put 1 wherever we see an x. Okay? And you've done some of those. I'm sure of it. So whatever we see inside here, that's what we're going to put in for x. Okay? It doesn't matter. See, that's our input, right? That's our input. So we put 1 in here. I get 3. Okay? 1 squared is 1 times 2 plus 1, 3. All right, now let's try this one. So wherever I see an x, I'm going to put this negative x in there. And I'm going to write it like that. Okay, so that hopefully you kind of see what's going on. All right, wherever I see an x, I'm going to put that negative x in there. So now I have negative x squared. Okay, I'm going to square that negative x. Well, what does that become? What's a negative x squared going to be? Positive x squared, good. And then this is just going to be a negative x, okay? That's all I can do with that. That's all I can do. But the main idea is wherever I see x, I'm going to put in negative x. Same with this one, all right? Same thing. Wherever I see x, I'm going to put this x plus 1. So I'm going to put this in here, okay? I'm going to put this in here, and I'm putting parentheses around it, hoping that you'll see what we're doing. We're putting this there. Oops, well, not quite there, but into 2x plus 1 here, right there, right there. Okay? Now, if you left your answer looking something like this, I would say that I'm not going to mark that wrong because you did it right, but I'm going to say this. Most of your math instructors are going to say, I want you to simplify this all the way out so it looks like, and figure it out, okay? That's what they're going to say. We're going to FOIL that. You guys know how to FOIL, right? Everybody knows how to FOIL, okay? I'm going to FOIL this. X squared, 1x, that's 2 x's, plus 1. And then I'm just going to tail this at the end. 2x squared plus 4x plus 2 plus x plus 1. Finally, I can finish this. All right, so if you look in the back of your book, and you had this problem was an actual problem, that's what they want it to look like this, okay? All right. Me, I'm okay with that. I'm probably a little more happy with the part there, and I might say something like, well, you might want to simplify that out, but at least you're showing me that I understand what I'm doing, okay? Last one. So wherever I see x, I'm going to put this now. So I got 2 parentheses 2x squared plus 2x. This one's an easy one to simplify out, so I should probably do it because this one's easy. And there's that one. Okay. Any questions on what we're doing there? If you have questions, you got to ask, because I don't know if you have questions or not. So there's some problems like that. Okay. And then there's some things with operations on functions. I would do that. Okay. Now, if I had a little more time, I'd probably do something different with this, but I'm just going to do this. Okay. So here's what they want us to do. They want us to add. So this is how we say this. F plus g of x, f minus g of x, f times g of x. All right? That's how you say that. F plus g, f minus g, f times g. So what we're going to do is we're going to take these two functions and we're going to add them, subtract them, and multiply them. All right? That's all they're asking you to do there. So here we take the f function. I'm going to write this out. Now, when you're doing your assignment, you don't have to write it out like this, but I'm just doing it to kind of show you what's going on. All right? I'm not going to get too excited. If you give me a good answer, and I'll be happy. So see, I'm adding this one and adding this one. Okay? I'm adding. It's all we're doing. So now I'm just going to add this up. X squared plus 4x plus 11. All right, I'm just going to add those two functions. Doesn't matter what they are, I'm just going to add them. F minus g. I'm going to subtract them this time. F minus g. All right, so I'm going to go F, 4x plus 8, minus g, x squared plus 3. Notice I put parentheses around that because, I'm just going to shove this down here, because I need to subtract not only the x squared but also the 3. All right? So I want to make sure I know I'm subtracting this whole complete function here and not just part of it, doing the whole thing. So 4x minus x squared, so I'm just going to get a negative x squared. I have nothing to do with the 4x, nothing's happening to it. I have a plus 8 minus a 3, should give me a 5. There's that one. And f times g. So now I'm just going to multiply them. There's nothing here that, you just don't let the symbolism get to you. All right, so now I'm just going to multiply them. 4x plus 8 times x squared plus 3. So I just FOIL these and get the answer. There's 4x cubed plus 12x plus 8x squared plus 24. All right? And then if you look in the back of the book, they'd probably do this. So it's written in decreasing order. Okay? All right. Add, subtract, and multiply them. That's all they're going to ask you to do. Okay. Any questions on those? You want another one, or are we good? We're good. Okay. Always remember, they actually did a study, and they said if one person in the room has a question, probably 5 other ones do in a room of 20. So don't be afraid to ask. That's 1.1. Okay. Switch some colors here. Let's go with this. this next part talks about graphs of functions. All right, I'm just going to graph one down here like that. Okay, so what are the important parts about the graphs of these functions? Well, the main important parts are here. All right, those are your x-intercepts. Sometimes they're called zeros, and sometimes they're called roots. All right, this is all the same thing. Okay, but they mainly are talking about x-intercepts in here. They don't really mention, oh, they do mention zeros, x-intercepts, and they do mention zeros. I don't think they mention roots, though. All right, but you're going to see those two words, but they're the same thing. X-intercepts, zeros, roots, all the same thing. All right. Domain and range. Okay, they're going to ask you about that. What the domain is, what the range is. What is the domain of this? All real numbers. Okay. Yeah. It's going to continue on. If I collapse it down, it's covering everything on the x-axis. All right. What about the range? All real numbers, right? It's going on forever. All real. All right. All real. Okay. They're going to ask you that. They're going to ask you the y-intercepts. Now, to this day, I don't know why they ask you the y-intercepts on a polynomial function like this, because it really doesn't have much meaning, but they'll ask you what it is. Okay? Then they're going to ask you, they'll put some points on here. Let me put a point on here. I'll put it in blue or something. There we go. Let's say it's 4. They're going to say, okay, what is f of 4? Well, you would go over here to 4 on the x, go down to where it hits the graph, go back over on this. Oh, it's 2. That's what it is. F of 4, here's 4. I go back to the y-axis. What's its corresponding point? That's 2. Okay, let's say this is negative 1. 1, 2, 3, 4. Okay? What about f of negative 1? Well, here's negative 1. I go up to the graph. I go back this way. Well, it's 3. All right? They're going to ask you questions like that. And they're probably going to put the points on there for you. Okay, but did I mess up? Yeah, I meant negative 2. Thank you. So we'll do an example in Desmos. I'll ask you some questions about it too. All right, so there are some things they're going to ask you. They ask a whole bunch of stuff. We'll go through some of them. I'll look at it for you. All right. The other things they're going to ask, they're going to talk about symmetry. Okay? So I'm going to give you a graph here. Looks like this. All right? Now, they're going to say, is this graph symmetric about the x-axis? Is it symmetric about the y-axis? Is it symmetric about the origin? Okay? So, if it's symmetric about the x-axis, that means that, here's the x-axis here. That means that if I took this and folded it down here, it should match up. Okay? So this graph here should be the same on top and the bottom. So it's like a mirror, okay, or a reflection, whatever you want to think of it. Since this graph doesn't have anything down here, it's not symmetric about the x-axis at all. What about the y-axis though? If I drew these nicely, would it be symmetric that way? Yes, because I can fold this over, it's going to match up. Okay? All right, so yes on the y-axis. On the origin basically means that if I take this graph and move it so it's 180 degrees, so this goes this way, this is going this way, so again I would have to have something down here in order to make that work, and I don't, so it's only symmetric about the x or the y-axis. So yes here, no here, and no here. That's what they mean by that. X-axis, y-axis, origin. Okay, I try to draw this a nice curve here. There. Symmetric about the x-axis? Yes or no? No. Looks like it is, but that would have to fold up there, correct? Okay, this would have to fold down. Sweet, so no. Symmetric about the y-axis? Okay, this would, if I mirrored this over here, it'd have to be this way. So no. And the origin, kind of hard to see that one. So if I rotated this thing 180 degrees this way, okay, so it's kind of weird, but yeah, it's going to be okay. All right. Okay, so that's that stuff. All right. So let's jump back into Desmos here. So I'm going to pause this guy.